The story of the Sukhoi Su-35S is one of a legendary military and modern-day mythmaking. For years, Russian state media has praised it as a 4++ generation fighter, a technological bridge to the future, and a dominant force that supposedly outmatched anything the West can throw at it. They boast of its super maneuverability and a radar so powerful it can see you from space. This video is not a fan letter, it's a reality check. The following analysis will place the Su-35s on the operating table to dissect its advertised strengths and prove that despite its intimidating looks, it's a product of an outdated design philosophy that firmly places it a step behind its modern Western rivals. The modern Su-35S, which first flew in 2008, is a different aircraft but reuses the same name. It is officially designed a deep modernization of the Su-27M. This new version removed the basic canards but incorporates powerful three-dimensional thrust vectoring engines. This program was a pragmatic response to Russia's post-Soviet economic realities. It was designed to fill the technological gap between the aging Su-27 fleet and the long-delayed, not true, 5th generation Su-57 program. The fact that it reused a name from a failed 1990s prototype is a clever marketing strategy. It creates a false impression of a continuous successful lineage, when in reality the Su-35S is a highly capable but fundamentally modernized decades-old airframe rather than a groundbreaking new design. This context is crucial for understanding its inherent design limitations. The centerpiece of Russian propaganda about the Su-35S is its NO-35 Airbus-E radar. State-controlled media and official sources proudly claim the radar has a detection range of up to 350 km against a 3 square meter RCS target and overall 400 km instrument range, can track up to 30 targets and engage 8 of them simultaneously. These are indeed impressive features, but they conceal a critical truth. The claimed 350 km range is not a general operating capability. It's a feature achieved only in a acute search in a tiny field of view, 10 by 10 degree. In a normal wide area search mode, the detection range for a similar target shrinks to approximately 200 km, and even then with only a 50% probability detection. This is a decent performance, but it's hardly the best as claimed. The root of this disparity lies in the fundamental technology of the radar itself. The Airbus-E is a passive electronically scanned array PSA radar. This is a single greatest vulnerability. In a PSA radar, all the radiating elements are connected to a single central transmitter and receiver. This means the radar can only emit a single powerful beam at a single frequency at any given time, which severely limits its functionality and makes it liability in a modern electronic warfare environment. This contrasts sharply with modern Western fighters like F-15EX, Eurofighter Typhoon, and the Su-35, which are equipped with active electronically scanned array (ESA) radars. An ESA radar has thousands of tiny transmit-receive modules, each acting as an independent mini radar. This design choice creates a dramatic technological gap that impacts nearly every aspect of air combat. First and most importantly is the issue of electronic warfare. The Su-35's single-channel PSA radar is extremely vulnerable to jamming. It's like trying to talk over a loud single-frequency megaphone in a crowded room. Meanwhile, the ESA radar can emit multiple frequency dial beams simultaneously, making it far more resilient to jamming. Second, the Su-35's powerful PSA radar, with its peak output of 20 kW, must operate at extremely high power levels to achieve its advertised range. This makes the aircraft a highly detectable target for passive enemy sensors. Usually, Russians focus on this 20 kW peak power, ignoring much more useful and reliable average power rate. Because Airbus E radars have average power just 5 kW below the 5.6 kW average power of an APG-83 SABR radar for F-16 Block 70s. Approximately an APG-83 radar can detect 3 square meter RCS target with 50% probability from 220 km. Finally, EZ radars are vastly superior in multitasking because each TR model can operate independently and EZ can simultaneously search for air targets, map the ground in high resolution, and act as a detailing or jammer. A PZ with its single-channel design cannot perform these functions with the same efficiency. This highlights a critical design flaw. The Su-35's radar is a powerful but inflexible one-trick pony in a world that demands a networked, multifunctional sensor suite. Modern aerial warfare is increasingly decided at a beyond visual range, where the winning strategy is not to outmaneuver the enemy in a dogfight, but rather to detect them first, fire a long-range missile, and then just run away. The Su-35's impressive aerobatics are largely party trick in this environment. Su-35's main BVR combat missile is R-77-1 Adder missile. Estimates R-77-1 range against transonic target in 10 to 12 km altitude is just about 70 to 80 km. Its results taken from Ukrainian war footages. Yeah, this is below the Western AIM-120D and Meteor series air-to-air missiles with max range beyond 180 km. The Su-35s can carry a formidable arsenal with maximum payload of 8,000 kg on its 12 external hardpoints. This allows to carry a mix of air-to-air, air-to-ground, and anti-ship munitions. Its most feared air-to-air weapon is the R-37 X-Head, a hypersonic, very long-range missile with a reported range of up to 200 km designed to target high-value assets like airborne early warning aircraft. R-37M missiles estimate burn time at the moment around 25 seconds after the burning missile lofts into high altitude, but at 100 plus kilometer long range it loses terminal speed so quickly, radically reduce own probability to kill. Russian state-affiliated sources often promote the Su-35S as a bargain on the international arms market due to its low unit cost and estimates around $47 million price. This makes it an attractive option for nations that may not be able to afford more expensive Western fighters. However, this is a textbook example of sticker price versus the total cost of ownership, and the numbers reveal a very different story. The Su-35 has a high cost per flight hour, reported to be around $23,000. This is not a bargain, it's more expensive to operate than the French Rafale with 16,000 euro per hour and the Swedish Gripen E 8,000 euro per hour. Perhaps even more damning is the aircraft's low operational availability. While the Rafale and Gripen E boast availability rates of 75 to 90% and 85 to 95% respectively, the Su-35's availability is dismal 40 to 60%. This is a catastrophic failure for a military, as it means that at any given time a significant portion of the fleet is ground for maintenance. A commander buying the Su-35 is not getting a bargain, they are getting a fleet that is cheap to acquire but expensive to operate and unreliable when it counts. This is a massive disadvantage in any sustained conflict. The Sukhoi Su-35S is a technical marvel and masterful modernization of the Su-27 airframe. It's a capable fighter, one of the best of its kind and testament to Russian aerospace engineering. However, its design philosophy is rooted in a bygone era of air combat where raw power and maneuverability were considered paramount. The conflict in Ukraine has shown that these vulnerabilities are not theoretical, they have real-world consequences in a high-intensity conflict against a technological advanced foe. The Su-35s may be the best fourth-generation fighter of its lineage, but as the evidence has proven in the modern battle space, that is simply not enough. Thanks for watching. If you like this video, please subscribe and share.